Hey everyone, welcome back. Now, before we get started today, I would like to go through a few reminders for this week. The first one is the Google Form password. At some point in this video, you will see a password. Make sure you submit your password in the document that was attached with this video. Next, when uploading your notes and practice problems, to get those perfect scores, please make sure you look at rubrics, okay? One is strictly based on notes and the other is for the practice problems. Also, when submitting your work, make sure your images are clear and legible. Next, your exit slip. Please, please, please take your time to complete the exit slip. This is not timed, but it is graded on correctness. So before pressing that submit button, make sure you are 100% sure of all of your answers. And last is the homework. Once again, there is a rubric also attached to the homework on how you will be graded. So please review the rubric before submitting your work there as well. Now, all of these assignments, there's 4 things. All of these assignments are due on Sunday, May 3rd by 11:59 p.m. Please, please, please do not wait until last minute to submit your work. Take your time, pace yourself throughout the week, look at the pacing calendar that was provided to you all, and see if that can help you work better in submitting all of your work on time. All right? So let's get started with our work. So what we're doing today is how do we translate systems of linear equation word problems. So I know we all hate word problems, but it's not that bad. As long as we know what we're doing, we got this, all right? So our objectives are, well, just one. We want to be able to set up the equations based off of real life situations in order to solve a system of linear equations. Now, we won't be solving anything in this lesson, but we just want to make sure we know how to set them up because we already learned how to solve systems of equations, all right? So the steps to setting up, we want to highlight the important information in the problem that will help write the 2 equations or the inequalities. Then we want to define the variables. Remember, variables are letters that represent unknown values, all right? So we want to know what are we trying to solve for, and then what don't we know, all right? And then we want to write the 2 equations or inequalities. So we want to know what does each equation or inequality relate to. So it's going to make a little bit more sense as we're going along. So just be a little patient, okay? All right, so here's our first question. It says the Celluloid Cinema sold 150 tickets to a movie. Some of these were child tickets and the rest were adult tickets. A child ticket costs $7.75 and an adult ticket costs $10.25. If the cinema sold $1,470 worth of tickets, we want to write a system of equations that could be used to determine how many adult tickets A and how many child tickets C were sold, okay? So it's a lot of words, but first thing we want to do is highlight some information. So let's see, what can we highlight? Oh, what's happening? Nope. Uh-oh. Little technical difficulty, but we're back. All right. So the first thing we want to do is highlight, like I said. All right. So the first thing we see here is it sold 150 tickets to a movie. All right. Then from there, we know a child ticket costs $7.75 and adult tickets cost $10.25. We also know it sold $1,470 worth of tickets, all right? So now we want to write the system, and it also says adult tickets are represented by A, and child tickets are represented by C. Okay? So, what can we do? All right. So I'm hoping we all identified that the overarching topic are tickets. But now we have two different types of ways we're talking about tickets. One is just talking about the amount of tickets we sold, and one is talking about the cost or the total cost of the tickets. Okay. So the first thing we should be able to identify is one of our system of equations will be talking about the amount of tickets. And the other one will be the total cost of tickets. So how do we know it was an equation? It says we sold, so we know we have a finite number, meaning we have a specific number that we want to get to, okay? So if we're looking at amount of tickets, we know that we have 150 tickets. So we know it's going to say equal to 150, okay? And then when it says total cost of tickets, we know we're going to have a total dollar amount, which is 1,470. Okay, so now what goes on the other side? So we need to define the variables, but the variables were already given to us. So we must use the letters that they gave us. So we know that A is going to represent our adult tickets and C is going to represent our child tickets. So now for our first equation, does it tell us that we had sold twice as many adult tickets than child tickets? No. So they're just telling us that we sold child and adult tickets. So the way we will write that is A plus C. We don't know how many adult tickets and we don't know how many child tickets, but we just know we had a combination of adult and child tickets. Now our second equation talks about the value, how much it costs. So link the things that we highlighted to represent cost. If I were talking about the adult tickets, how much does an adult ticket cost? $10.25. Now, if I bought one adult ticket, it will cost me $10.25. If I bought two adult tickets, it will cost $20.50. If I bought 10 adult tickets, how will I find out the total cost? I would do $10.25 times the amount of adult tickets. So that will be written as $10.25. I don't know how many tickets, so it'll just be A. And then same thing with the child tickets. I don't know how many child tickets I bought, but I know that each child ticket is worth $7.75. So that will be plus $7.75 C. Okay? Not so bad, right? I hope not. All right, let's check out the next one. So now this one says Jack bought 3 slices of cheese pizza and 4 slices of mushroom pizza for a total of $12.50. Grace bought 3 slices of cheese pizza and 2 slices of mushroom pizza for a total cost of $8.50. We want to write a linear system of equations that models this scenario. So let's get some highlights in. So the first thing is, what is our topic talking about? Pizza. Who doesn't like pizza? All right. So we know that we have 3 slices. Uh-oh, wrong thing. Highlighter. We have 3 slices of pizza, cheese pizza, and 4 slices of mushroom for a total of $12.50. Then we also have 3 slices of cheese pizza and 2 slices of mushroom pizza for a total cost of $8.50. So this problem looks a little bit different. What do you think we need to do in this case? First thing is we need to define the variables, okay? So what are we talking about? We need to talk about two different variables in here. So what do you think our two different variables can represent? First variable will represent the cheese pizza. And our second variable will represent mushroom pizza. So if you notice in the two scenarios, they both spoke about pizza. So does it matter in this case what letters we use? No, the question did not define what each pizza or each type of pizza we would use. So I'm just going to say X is going to represent my cheese pizza and Y is going to represent my mushroom pizza. Now, what are two systems of equations representing? The first equation is going to represent Jack's purchase, and my second equation is going to represent Grace's purchase. Okay, so let's talk about Jack. Jack bought 3 slices of cheese and 4 slices of mushroom for a total of $12.50. So we have 3x plus 4y equal to $12.50. Right? Okay. And then we have Grace, where she bought 3 slices of pizza and 2 slices of mushroom for a total cost of $8.50. So we have 3x plus 2y equal to $8.50. So just to talk about this one a little bit more further. If you notice, the two sentences spoke about the same exact things, talk about the 2 types of pizza and the amount that it cost. So that's how we were able to determine that we're talking about 2 different purchases, one relating to Jack and one relating to Grace. So remember, the 3x came from, it says 3 slices of cheese pizza. So we have 3 slices, and then cheese pizza is represented by X. And 4 slices is the 4 here, and we're talking about mushroom pizza. And mushroom pizza is represented by Y. And the total for that order was $12.50. And the same thing applied to Grace. We have 3 cheese, which is 3x. Remember, cheese is X. And then 2 slices of mushroom. And Y represents mushroom. Okay? And her total was $8.50. All right? Next one. All right. So it says a recreation center ordered a total of 15 tricycles and bicycles from a sporting goods store. The number of wheels for all the tricycles and bicycles totaled 38. We want to write a linear system of equations that models this scenario where T represents the number of tricycles and B represents the number of bicycles ordered. So I want you guys to pause the video and take about, I'll say 30 seconds and see if you could identify the 2 equations, okay? All right, so first thing I want to highlight, I'm going to use the yellow. I don't like this red so much. All right, so we have a total of 15 tricycles and bicycles. Then it says we have a total of 38. But what is this 38 representing? The number of wheels for both the tricycles and the bicycles. Okay? Then we also have T represents the number of tricycles and B represents the number of bicycles. So what can my equations look like? So the first thing is we have 2 totals once again. One is representing 15, one is representing 38. And our topic in this case are the wheels. So first thing, I'm just going to write it down on the side because it helps me. I'm hoping you might do the same. So T represents the number of tricycles, and B represents the number of bicycles. Okay? So my first equation is talking about the amount because it says we have total. So we have amount of everything, amount of, I'm just going to abbreviate, tricycles and bicycles. Okay, and then the next one is just talking about the number of wheels. So we have number of wheels to both. Okay, so when we're talking about the amount of tricycles and bicycles, we know that we have a total of 15. But as I said before in the first question, does it say we have more tricycles than bicycles? No. So this one will be just T plus B equal to 15. Okay, now our second equation is talking about the number of wheels. So now we just have to take a little bit more into consideration what the question is asking. We're talking about wheels. So do tricycles and bicycles have the same amount of wheels? No. How many wheels are on a tricycle? What word do you see there? Tri. And that tells us we have 3 wheels. So I'm just going to write 3 up here, okay? And then for bicycles, how many wheels does a bicycle have? I hope you guessed it, 2 wheels, okay? So now that we're talking about the number of wheels, if I'm talking about tricycles, if I had 1 tricycle, how many wheels would it have? 3. If I had 2 tricycles, how many wheels would I have in all? 6. How did you do it? You had to do 3 times the amount of tricycles. So we have 3T. And then if we're talking about bicycles, same thing. If I had 1 bicycle, how many wheels do we have? 1. If I had 10 bicycles, how many wheels would I have in all? 20, because 2 times 10 gives me 20 wheels. So this will be 2B, but this question is saying we have a total of 38 wheels. So we would write 38 here. Easy? I hope. All right, so it's break time. So pause the video, take a break, come back. Doesn't have to be today, but make sure it's sooner than later, all right? I'm gonna take a break too, so I'll be back. All right. All right, so I'm back. Okay, moving on. So our next lesson is how do we translate and solve systems of linear inequalities word problems. So we're not going to be solving all of them. I'm just going to show one example, so don't fear, okay? All right, here we go. So our learning objectives for this one will be able to write an inequality to represent the given situation and then solve the application of systems of linear inequalities. Okay, so before we get into that, the steps are the same. We want to highlight the important information in the problem. We want to define the variables, and then we want to write the 2 inequalities in this case. But before we get into actual inequalities, we just need to go over a few common words, okay? Now, remember, inequalities mean that it does not always equal. We could have multiple answers, okay? So some of the words that we need to familiarize ourselves with are more than, less than, no more than, no less than, maximum, minimum, at most, and at least. So before we move on, let's just go through these really quickly. So I'm suggesting, but you don't have to do what I do. I suggest when you're looking at these words, put it into a sentence and then see which inequality you can think of. Okay? So you need more than, I'm going to use the same scenario for the most part, okay? You need more than $50 to go to Six Flags. So what does that mean? You need greater than $60. So more than represents the greater than symbol. So if more than means greater than, you need less than $50 to go to Six Flags. So that means less than. Okay? Now, the next one. You need no more than $20 to buy a bag of Skittles. Skittles. No more than. So that means $20 or less. Okay? Then we have minimum. You must be a minimum of 48 inches to get on the ride. So that means you have to be 48 inches or more. When I was younger, I couldn't get on any rides. I was too short. All right? Anyways, maximum. You need a maximum of $60 to go to Dave & Buster's. So that means you need $60 or less. Okay? You need at most $500 for the new Yeezys. Probably not, probably more. All right? So at most means you have the $500 or less. Okay? So if at most means less than or equal to, at least means greater than or equal to. You need at least $30 to go to the supermarket. Okay? And then no less than means, what do you think? Greater than or equal to. Okay? All right. So here we go. What's happening? All right, here's our first question for inequalities. All right, so now in order to prepare for your end of summer bash, hopefully we get that right, you go to the supermarket to buy hamburgers and chicken. Hamburgers cost $2 per pound and chicken costs $3 per pound. You have no more than $30 to spend. You expect to purchase at least 3 pounds of hamburgers. We want to write a system of linear inequalities to represent the given information. So, like we did before, we need to highlight, all right? So, the first thing is, we know that we have hamburgers that cost $2, and we have chicken that costs $3. And if you notice, the units are the same, so we don't really need to write that or highlight that, okay? And then we want to have no more than $30 to spend, okay? Then it also says you expect to purchase at least 3 pounds of hamburgers, okay? Now, another key piece of information, it sometimes helps, all right? Well, it should help all the time. If you notice, what is the question asking us? A system of linear inequalities. So once we see the word inequalities, we know that we should be using the symbols greater than, less than, greater than or equal to, and less than or equal to, okay? So now that we've highlighted, I'm hoping that you guys were able to identify that the topic is just talking about food, burgers and chicken, all right? So next thing we want to do is define the variables. In this scenario, they did not identify what letters to use, so we could pick our own. So I'm just going to use H for hamburgers. And C for chicken. Okay, so what do you think our two inequalities are going to be talking about? The first inequality is going to be talking about the money, and then our second inequality is just talking about the amount of, in this case, amount of food, okay? So the first one, now, if you notice, it says cost is $2 for hamburgers and the cost for chicken is $3, and we want to spend no more than $30. So we could set up the two sides. All right, the first side will be 2H plus 3C, and then the other side of our inequality would be 30, okay? Because we know that we're spending money, so we have to talk about the money to relate back to the money, okay? So remember the words no more than. You have no more than $30. What does that mean to us? You have $30 or less. So we use the less than or equal to symbol, okay? Now the next one, it says you expect to purchase at least 3 pounds of hamburgers, okay? This one might be a little tricky, but let's talk about it. What are they talking about in that particular piece? Just hamburgers. Did it mention anything about the chickens, about, well, purchasing the chicken? No, it only told us that we have, that chicken costs $3, but it did not tell us we need to purchase a certain amount of chicken. So do we need to put that in a part of our inequality? No. So not always we will use both variables, okay? So in this case, they're just talking about the hamburgers. So we have H, and then it says we want to purchase 3 pounds of it, okay? Or so we could have talked about the weight, okay? So at least, what does at least mean to us? You need to be at least 48 inches to get on the ride. That means 48 or more. And there we are. Okay, next one. It says Jordan works for a landscape company during his summer vacation. He is paid $12 per hour for mowing lawns and $14 per hour for planting gardens. He can work a maximum of 40 hours per week and would like to earn at least $250 this week. If M represents the number of hours mowing lawns and G represents the number of hours planting gardens, write a system of inequalities that could be used to represent the condition. Okay, so let's get going on this one. All right, so the first thing is we're talking about Jordan working for a landscape company. So in this landscape company, we know he is paid $12 an hour for mowing lawns, $14 per hour for planting gardens. He wants to work a maximum of 40 hours. And he wants to earn at least $250. Okay? M represents the number of hours mowing the lawns, and G represents the number of hours planting gardens. And remember, it's a system of inequalities, so that means we have to use those symbols other than the equal sign. Okay? So I'm just going to write my notes. So M represents the mowing lawns, and G represents planting gardens. Well, the number of hours, okay? So What do you think our two inequalities are going to be talking about? The first inequality is talking about the hours that he worked. And then the second inequality is talking about the money that he's earning. Okay, so let's look at it. If we're talking about the hours worked, once again, did they mention that he worked more, he wanted to do more hours doing one job than the other? No. So we have M plus G, then on the other side is 40. Now maximum, once again, what does maximum mean? It's our highest point. All right, think about it. Hey, quadratics, we spoke about it there. But anyways, maximum means our highest point. So it means that we have to do 40 hours or less. So we write the less than or equal to symbol there. Okay, and the way we read it is less than or equal to 40. So it makes sense, right? All right, and then the next one we're talking about, he wants to earn at least $250. So now keep in mind, if we're talking about earning, we have to take into consideration the value of what everything is worth. So same examples. If we worked 1 hour mowing lawns, how much money would I make? 12. If I worked 3 hours mowing lawns, how much money would I make then? What's the quicker way to solve that? You would do 12 times 3, okay? So we have 12M plus 14G, and we know that we're going somewhere around 250. So once again, what does the words at least mean? Greater than or equal to, okay? And here we go. Next one. It says a company manufactures bicycles and skateboards. The company's daily production of bicycles cannot exceed 10, and its daily production of skateboards must be less than or equal to 12. The combined number of bicycles and skateboards cannot be more than 16. If X is the number of bicycles and Y is the number of skateboards, write an inequality system that represents the number of skateboards and bicycles that the company can manufacture daily, okay? So this is talking about bicycles and skateboards, but then let's go through the problem. It says bicycles cannot exceed 10. Daily production of skateboards must be less than or equal to 12. And then we have a combined number of bicycles and skateboards cannot be more than 16. We also have X is representing the number of bicycles and Y is representing the number of skateboards. So there's a lot going on in this particular problem, okay? How many inequalities do you think you'll see in this particular problem? Let's go through it. So our first one says, before I do that, let's write it down. X is representing our bicycles and Y represents our skateboards. Now, why am I using those letters? Why didn't I use B and S? It says it in the problem that we need to use X and Y, okay? All right, so next, it says the company daily production of bicycles cannot exceed 10, and the daily production of skateboards must be less than or equal to 12. Now, it's all chunked into one sentence, right? But when it comes to systems of inequalities, systems of equations, we only write one inequality or equal sign when it comes to writing these out, okay? So that means although it's in one sentence, we have to separate them, okay? So the first one is bicycles cannot exceed 10. So I have X and 10. What does the word exceed mean? cannot go over. So it has to be 10 or less, okay? And then it says skateboards must be less than or equal to 12. Well, that's easy. They already told us what symbol to use. Less than or equal to 12, all right? But wait, there's another sentence that we highlighted. Systems of inequalities or equations just means it has to be at least 2 or more. So we have a third one in this problem. So this one says a combined number. Combined means we're talking about both. So that means we're going to be adding something in this case, right? Cannot be more than 16. So we have x plus y, and then we have 16 over here. Cannot be more than. What does that mean? We cannot go over 16. So that means it's going to be less than or equal to 16. Okay? All right. Da, 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 final one. All right. I know I give a lot. I'm sorry. I want to make sure you guys get this. Okay? All right. Last one. A high school drama club is putting on their annual theater production. There is a maximum number of tickets for the show. The costs of the tickets are $6 before the day of the show and $9 on the day of the show. To meet the expenses of the show, the club must sell at least $5,000 worth of tickets. So now we have two parts that we're going to work through on this one, all right? First one is we want to write the system of inequalities that represents the situation. And then the second part says the club sells 440 tickets before the day of the show. Is it possible to sell enough additional tickets on the day of the show to at least meet the expenses of the show? And we want to justify our answer. So before we get to that, let's just talk about A. Let's write the systems, but we need to highlight first, okay? So the first thing is we know we have a maximum of 800 tickets. Cost of tickets is $6 before the show, the day of the show, and $9 on the day of the show. So make sure you see those two words, $6 before and $9 on, okay? And then to meet the expenses, we must sell at least $5,000 worth of tickets. Okay, so pause the video and see if you could come up with the two inequalities. Okay, and then come back. All right, so if we're talking about this, first thing, once again, we need to identify letters. Did it tell us what letters to use? Nah. So we're going to say X is going to represent before the show, and Y is going to represent on the day of the show. So this is the day before, X is the day before the show, and Y is the day of the show, okay? So our first inequality, we want to talk about maximum of 800 tickets. So this should be X plus Y, and we have 800, and once again, maximum means, think about the auditorium that we have at the school. It says maximum people is, I don't know, 360. What does that mean? 350. Well, whatever. It means we cannot go over that amount. So it has to be less than or equal to, okay? Our second inequality is talking about we need to have at least $5,000 worth of tickets sold. So when we talk about money, I like to say money goes with money. So what talks about money here? $6 and $9. But once again, those words behind it mean something. So if I'm saying $6, what does $6 represent? before the day of the show. So that will be 6x plus, fill it in, 9y, and then we have 5,000. Now, what does at least mean? It's going to be greater than or equal to. Correct? All right, so the next part. It says the club sells 440 tickets before the day of the show. Is it possible to sell enough additional tickets on the day of the show to at least meet the expenses of the show? And we need to justify our answer. So, what does expense mean? Money, we're spending. So, which inequality do you think we're going to be using? The second one. Okay, so it says 6x plus 9y greater than or equal to 5,000. But now what do we know? It says the club sells 440 tickets before the day of the show. What did X represent? The day before the show. What did Y represent? The day of the show. So in this case, we're using before the show. So that represents our X value. So now we're going to substitute in 444x. Okay? Now, when I use my handy dandy calculator, I get 2,640, and then I continue with the rest of my problem. From here, remember, we solve like an equation, so we want to get that y by itself. So we're going to subtract 2,640 from both sides. And we get 2,360. Then we divide both sides by 9. And we get y. This becomes 262.2, and it repeats. Now, does my inequality stay or does it flip? It stays. Now, so before I continue, just remember, it flips only when we multiply or divide by a negative value, all right? But anyways, y is representing the number of tickets sold on the day of the show. But can I sell 262.2 tickets? Is that possible? No. So this will round to 263 tickets. Okay, because it says y has to be greater, so we have to sell at least 263. Now, we are not done. We want to know if we have enough additional tickets on the day of the show. So all we have to do now is plug everything into the first equation, because that's talking about the amount of tickets. Okay, so if I have x plus y less than or equal to 800, what is x? X is 440, because we said that's how many that were sold before the day of the show. Do we know what y is now? Absolutely. It's 263. And now it's just a check question. 440 plus 263 is 703, less than or equal to 800. And is 703 less than or equal to 800? Absolutely. So yes, we do have enough tickets. We have enough tickets. Okay? Now, justify your answer. This is a way to justify your answer, okay, by showing all of this math. Another way you could have shown justification is by explaining what your answer might be, okay? So just keep that in mind. There's no one way of justifying, but if we were to explain, that completely means we must use words. All right? Well, that's all for now. Until next time. All right? See ya.